So I just tried streaming and already messed it up. So I'm going to try again. Yeah, so I wanted to make a video and a stream here about trying to write some unit tests for a bit of code that I was referring to in a couple other videos I just made. So I'm finally getting around from the system design part of it to writing tests on some of the classes I made. And in particular, so the background here is I have a loot generator class for a role-playing game, and I want to be able to cover it with some unit tests. So I want to follow up at another point, maybe with another video or something, where I talk about why I want to put unit tests here and not other types of coded tests. But I just want to focus on writing unit tests for this discussion here. So we can see that I have a loot generator class, and what's publicly exposed that I want to write unit tests for is this generate loot method. So I'm going to kind of walk through the tools I use for writing unit tests. Obviously, this is in C# and inside of Visual Studio. And to start, I mean, the things that I really like using for writing my unit tests are xUnit, which is a unit testing framework, and mock, which allows you to, it's spelled MOQ, but it's to mock, MOCK, out implementations of interfaces. So what this lets you do is, as you're calling code, it lets you control the things that you're calling because they're mock implementations you've set up. So super quick example is that if I had a mock passed in when I call this drop table repository, when this method gets called, I can actually set up a mock object that returns what I want when this method's called. And the reason why this is really cool for unit tests is it lets you control the flow of the code that's being exercised. So with that said, the unit test is going to allow you to direct flow of logic throughout what you're exercising, but because you're using mocked objects, you're pretending what the behavior of these called objects is going to be. So that's just something to keep in mind. Just a quick counter example is that if I wrote all of my tests and assumed that get all drop tables could never throw an exception, but in reality it's very likely that it could or able to throw an exception, that would mean that I don't have sufficient test coverage on this method, generate loot, to ensure that it's safe to call this. So I just wanted to kind of illustrate that. But again, I want to follow up with another video or a stream about different types of coded tests you can put in place to kind of cover that. So to get started, I have this class loot generator inside of this project, which is ends with game objects items generation, and you can see that over here. It's highlighted in blue. And I've already gone ahead and I've made a test project, but what I would do is I would add a, right click, add new project, blah, 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 add it all in. And the thing that's important here is that is your dependencies, right? So I guess Visual Studio already did that for me and it opened it up, but I've added in the xUnit NuGet package and the mock NuGet package. Another thing that's really important is I don't know when the xUnit changed it, but they made it such that their test runner inside of Visual Studio actually is a NuGet package as well. So if you're not using something else like JetBrains with their test runner, and you're using the built-in Visual Studio one, you actually want to make sure that you have the Visual Studio test runner for this. And I seem to not have it added in here, but it's running somehow. But usually, so whoops. But usually, what you would end up doing is, I think it's xUnit Visual. If I search xUnit Visual Studio Runner, oh yeah, it is here. Oh, I must have it for some other project, and it's caused this to get detected. So I'm not exactly sure how that works. So I assume it's only working right now because I have another test project that actually references this NuGet package. So it's able to discover tests properly, but regardless, I should go ahead and have it installed for this. So let's do that. This is the joy of doing things live and unrehearsed. So there we go. Have that installed. And what that's going to let you do is actually in your test explorer, you can see that I can actually detect the tests that are inside of my solution. So that's really important. Otherwise, we could go write all these tests, and you're like, great, we have all this code to exercise other code, but what do I do with it? You can call it on the command line, but I like working in Visual Studio and really being able to do something like right click and then run test. So yeah, so like you can see in this context menu, I can just literally right click and run test, it's really nice when I'm developing stuff. So what we're going to go ahead and do, I've pinned both these things up here because this is going to be the class I'm testing, specifically this method, generate loot. And this is my test class, right? So you need to make sure that your test project has a reference to the project that you want to write tests for. So in here, I absolutely made sure that I have, what's the name of this? Game objects item generation. So, oops. Right, so this one right here, this project reference is what I need to make sure that I can see this class and I'm about to go write tests for. Right, so the way I like doing that is, so I have my test class here, and the way xUnit works is that when you write your test methods, the constructor for your test class is called before every test method is run. So if you have two test methods and obviously one constructor for your class, for each test method, that constructor will get called, right? So if there's two test methods, your constructor gets called twice. So it's a really cool way to put common setup code. And because every test I'm going to run is going to be using a loot generator, I can do loot generator, and let me just resolve this. Come on. This is going to be the system under test, so all my test methods are going to be exercising this. Another thing that I like doing is I'm going to have a mock repository, and the way the mock repository works is that if you're not familiar with mocking frameworks, essentially what I'm allowed to do with it is, let me just write it out before I lose my train of thought. It's the thing that is going to provide the instances of the mocked objects. So let's start with these two things. So I'm going to make a constructor because this is going to be the setup code that must run before every test. So I'm going to start mock repository equals new mock repository, and I'm going to give it a mock behavior of strict, and I'll explain what that means. So when you have a mocked object, so let's pretend, let me actually just make one. So I don't know. Sorry, it's hard to type and talk at the same time. It's something I got to practice. So if I had this mock object here, right, when you call mock.object, it actually gives you the interface that you're mocking. So the things that I can call on this are generate loot, essentially. It's the only method on this interface, right? Okay, so when you're calling your system under test and it hits a line of code that has a mocked object, if you use a loose mock, it just runs nothing, right? And will give you if there's a return value on the method, it gives you the default of it. So what that lets you do is kind of just ignore that things are getting called. And in my opinion, when you're writing unit tests, the whole point of the unit test is that you're trying to prove that the lines of code you're expecting to run are running the way that you expect, right? So when you're using loose mocks, it makes it like you're literally saying, I don't care that this line of code got called. But if that's the case, why are you writing the unit test anyway, right? So I want to get into more detail on that in like a follow-up video, but I kind of just want to show like this is how you might set up and walk through some test scenarios. So anyway, we're going to be dealing with strict because it forces us to actually set up the mocked objects. if your system under test, when you're running through your lines of code, if it hits a mocked object that is not set up, right? So if you didn't set up the method on that mocked object, your test will fail right away. So it lets you know, like, hey, you're hitting a line of code, you didn't set this up properly, or you just forgot to, or someone made a code change. This method needs to be set up on your mock. Otherwise, we don't know what we're supposed to do, right? Okay, so get our mock repository set up. This will make a little bit more sense in a second after I write this line. So I'm going to make a new loot generator. It's not going to be a mocked object. And the reason why is I need the real thing here. However, my loot generator takes in a whole bunch of things. So it takes in a drop table repository. It takes in a drop table generator facade, handler facade. Naming things gets real crazy. So these names get really ridiculous. There's like over 80 projects in my solution. So as you're trying to come up with names for different domains and stuff, gets really challenging. So please forgive me for really long or weird names. I need an attribute filter, and I need a random number generator because we're dealing with a loot generator, and if there's no randomness to it, it's no fun. So what's the problem here? My loot generator has these 4 dependencies that I don't have yet, but that's okay because we're going to mock them out. And the reason we want to mock them out is I want to control the flow of code through my loot generator, right? Again, I'll follow up with another video on it, but if I put in the real drop table repository implementation, a real drop table handler, generator facade implementation, and real implementations for these other 2 things, that's okay. It's just not going to be a unit test. And the reason why is that I'm actually exercising other parts of the system, other dependencies, by passing in the real things. That's a functional test. That's totally cool too. It's just a different thing. So I have these 4 things, and I'm going to set up mocks for them. So the way I do that is I make a mock I drop table repository. Drop table. Sorry, this part, I like taking the time up front to do this because you'll see that if I'm writing multiple tests, all of a sudden it this little setup time that you do once, you don't have to pay down again, which is really nice. So a little bit of investment up front kind of sucks, but whatever. The other thing is when you're passing in these mocks, you need to pass in the object for them. Why did that? Oh, it's because I can't spell. There we go. Yeah, the joys of writing code live. So this needs a dot object as well. These ones aren't made yet, but they'll also need dot object. The reason why is because mock itself is a class, right? So I've made a mock, but this loot generator takes in the interface that we're trying to mock. So we give it dot object, which if I hover over, you can see in the IntelliSense. Dot object on this instance is a drop table repository, an iDrop table repository. And similarly on this one, the dot object is the interface. I just realized I'm pointing at my screen, so you can't see that I'm pointing at the interface name. But yeah, so you can see it in the IntelliSense there. So I need 2 more mocks. Like I said, this part's a little bit boring, but please bear with me. And I need an I attribute filter. So this is going to be located somewhere else. Thank God for that functionality, or else I wouldn't know where I put all my stuff. Okay, so cool. This is looking pretty good. So what this will do is we have a constructor. We don't have any tests yet, but our constructor will get called, and it's going to pass these things in. But if you're paying attention, you'll realize that I'm passing in a underscore drop table repository dot object here. I've never actually made this anywhere. Right? I've declared it. I've never assigned an instance to it. So if you're paying attention, you'll know that that would have exploded if I tried to run anything. And how we make them is we actually ask our mock repository to create what we're interested in, and we give it the type. Oops, that's not the spot. It goes over here. There we go. So when you ask the reason why we're doing it this way, this is so in my professional experience, what I've learned is that if you want to make more consistent, more concise tests, I think setting this stuff up in your constructor is really beneficial. The reason why is you can ask your mock repository to make these things for you. It forces them to be strict because you've declared it to be strict right on the repository. The other thing that we'll get to after we write our first test is that we can actually verify all the calls of all the mocked objects, not individually, but all at once. Because mock repository, and I'll explain what it means, but has this verify all method, right? And each one of the mocks that you make, so drop table repository, has a verify on it. But instead of me trying to call verify on all the mocks I have set up, if I just make them off of the repository, I can just call verify all right on the repository, and it'll verify all my mocks that I made with it. So really powerful. And if you don't know what verify all does, stay tuned because we'll get to it when we write our first test. But yeah, so over time I found that when you start to see enough duplicated code, or you find that you're doing this pattern a lot, you'll find little optimizations like this. Okay, so all I did was I actually made all of those mocks. I'll put some separation there. So we make our repository. We actually instantiate all the mocks off of the repository. So all of these are now made with strict behavior, which is great. So we want for our unit tests. And then we make our system under test. Cool. Now let's go write our first test. So the way this works is it's the xUnit framework is going to look for test methods. I like writing my test methods with a pattern that looks like this. So the first part is the method that we're going to be testing. And I think I said, oops, I just want to look it up really quick. It's called generate loot, right? So we put that right here. The part in the middle is generally the scenario that we're interested in running. And the part at the end is your expected result. And this is just a way that I've been practicing for writing tests that makes them that describes them well. So if you were to see a test running and pass, you can see, oh, like that's, even someone reading this code can say, I know what this test is supposed to be doing. And when you see it fail, you can see what scenario is is not being covered properly now because it's breaking. So that's I think a good way to name things. You can follow whatever pattern you like. I think it's just important that you're describing what's actually being exercised. So I don't know yet what these scenarios or result is going to be. I just know that we're calling generate loot. So just for the moment, I'm going to leave it looking kind of ugly like that. But what xUnit wants to do is it's going to be looking for something called a fact. Okay, so your fact is going to be the attribute you put on your test method that tells xUnit this is a test method. So when the test runner goes to run this, it will look through this class, which has to be marked as public. Okay, so your test class has to be public. It will go look for all of the methods labeled fact. And when it goes to run this, it will first start by running the constructor, like I said. So all this code will run. Then it will go run your fact. And if there was another fact, it would go run your constructor again and go run the next fact. Okay, so that way, anything that's actually shared, like as a field, like a variable inside your class, if it's not static, it actually is a new instance every fact that you get run. So that's pretty powerful. So it lets us reuse code without sharing the state, which you don't want to be doing in your unit tests. Okay, so to really understand what we want to be testing here, basically, I need to see what parameters I can pass in, right? So it's what parameters I can pass in, and then we're going to have a look at the code to see the different paths we can exercise. So in here, I have a generator context that can get passed in. Like the constructor, we don't actually have this reference. So we'll do the same thing. I'm going to go make a mock. So just before I do that, if you knew that, say you're only going to have like one test that looks like this, and so in my particular case, loot generator, as I mentioned, sorry, I just flipped over to the class. It only has one public method on it. If you had a class with a bunch of small public methods, it might not really be like there's no benefit to declaring your input as a field up here because you're not really reusing it in other tests. For what we're about to do, though, because I had a brief look at what the class looks like, we're going to have several tests that will always use a generator context. So that's why it makes sense to set it up once. My generator context comes from here, and we got to do the same thing so we don't forget, which means that we'll have it instantiated. Boom. Okay. So this is cool. And what I like to do is var result equals call the method. So I set things up this way. There's like this pattern in unit testing that people call, they have different names for it, but like it's like arrange. Oops, I can't type properly today either. Act assert. So you would do all of your, and the other way is that you call it setup. Do the thing. So just to explain it, so the arrange, act, assert pattern means that you set up everything for your test at the start of your method. Usually your act, or the part that's actually doing or exercising the code, is almost always a single line, right? You're just calling this method, right? You're exercising one thing on your system under test. Then you have a spot at the end that does checks. Okay, so that's cool. What we need, this is our act part. I used to label the sections of my test with arrange, act, assert. Started to not do that because I think that if you're finding that the tests you're writing are so large in lines of code that you need to label those sections, it might not be. It might be an indicator that maybe you should break up your coded, like the system under test. Maybe it's doing too much. So to me, I started to realize if I felt I needed to put these things in to label the sections, maybe I have a different problem. Sometimes when you're dealing with like actual production code, and you're coming through and you're like, hey, this code didn't have tests on it, I'm going to add some. Sometimes it makes sense that you have some really unwieldy code that you need to have a lot of, like, scary, but maybe like hundreds of lines of setup. It sucks, but the other option is that you either write a functional test, which you could totally do, or you do the unit test, you exercise your code path, and you have this bit of ugly setup. And if you don't want that, I mean, you could go ahead and try and refactor it. But if you don't have functional tests over the system you're trying to refactor, it can be pretty risky. So I'm going to put act here just to demonstrate. We're going to have an arrange part. Oops. And assert. Okay. So now that we have some of the framework for our test method set up, we have to go figure out what are we actually going to test here. So if we were to call this, right, like technically right now I could go run this test. I'm hoping it's going to explode, right? And it should, because some of these classes are going to have methods that get called, assuming that the body of this generate loot method isn't empty. So some of these should get called, and because they're strict mocks and nothing's set up, something should explode. Oh no, I bet you I put in that test runner project or NuGet package and it blew up. What? This didn't fail? Crazy. Okay, well, let's go read the code and see why I didn't. I didn't rehearse any of this, right? So that actually looks wrong to me. But when we are in doubt, we can go debug it. So yeah, literally didn't rehearse this. I figured this would be an easy class, and I'm already proving myself wrong here. So we have this loot generator. We're going to call generate loot with this context, right? So I'm going to step in. Oops, I didn't step in. Oh, I did step in. I know what happened. Okay, this is kind of funny. The little thing that I didn't notice is that this is an IEnumerable. And this will yield out items from this loot generator. So, a little lesson if you're not familiar with IEnumerables. An IEnumerable that is a iterator, or I guess, it's generating objects. It is just a function pointer. Okay, so all that happened, and it's not obvious, all that happened was I ran this line of code and it said, okay, generate loot, that's a function. And it doesn't actually call the function, it just assigns the function to this variable, which is kind of funny. So in order for us to actually exercise the code inside of it, we actually have to do something like force enumeration. So we can call toArray on this, and that's kind of funny that happened. And you'll see that all that I'm doing now that's different is I'm actually telling the code, go enumerate the things that come out of this, right? And we're going to assign all the things that come out of this method call to result. So now, when I run this, I bet money that it's going to explode. I'm not saying how much, though. So I right-clicked, I ran it, and you can see over here it's doing the exploration. It's going to go run this test, and it should be red. And it is. Cool. And kind of as expected, oh, that's really ugly. One sec. It says there's a mock exception. It says I drop table repository get all drop tables. Invocation failed with mock behavior strict. So that's what we want to see. All invocations on the mock must have a corresponding setup. That's exactly right. I didn't set that thing up. I don't know what I just did there because that's going to... Uh-oh. Anyway, sorry, I collapsed that a little bit too far. So that's exactly right. So if we go check the code out, I'm going to jump to it. You can see the first line of code after this comment says, go call get all drop tables on this drop table repository reference. However, as I said, this is going to be a mock for us. So we need to set it up with what we want it to do. So let's go do that. And before we go do that, I think it's a good opportunity. I was saying I don't actually know what the test scenario we want to run is. Right? So when I'm analyzing some code to think about the tests I want to run, I look at some of the control flow, right? So I can see we have a while loop, right? So I can see there's a while loop. I can see that there is a error checking scenario. So if this method's called and we get a null back, then we should explode. That's actually expected behavior. So it means that this hopefully is never null, but if it is, we have a good message that comes up that tells us what's going wrong instead of us guessing about a null reference exception. So there's a loop on the outside. There's this error checking scenario. And the other thing is we have a for each loop here, so another loop inside the loop. And then there is this check here with two different conditions. One is when remaining is 0, and one is when the generated count equals some maximum generate count. So already I can see there's a few different scenarios. We have two checks here because there's an and. We have a check here, and we have another two checks here. So yeah, there's a couple different things that we can dive into. Before we get to any of those checks, though, we can do some setups right up here on these two things. So drop table repository, get all drop tables, and attribute filter. So let's go look at what that looks like to go set these up. So I said drop table repository. How we set these things up is you call .setup, and it takes a method here. So this is how you would write it. Get all drop tables. It doesn't take any parameters, but it does return something. And what does it return? An enumerable of drop tables. Very cool. Okay, so this is an example of something I might actually not set up in my list of fields up top. Okay, the reason why is I have a feeling that I might write tests. I'm just jumping to the class now. I might write tests because this all drop tables. Actually, no. I take that back. I'll explain why I would have not put it as a field. If all drop tables, which is going to be an enumerable, is something that in this class that we were going to iterate over, I thought that maybe one of these loops did that. I might want to prove out what it looks like when we have nothing and when we have multiple things to iterate over. Those are two good testing scenarios to exercise when you have a collection that you're enumerating over. What's it look like when it's empty, and what's it look like when there's multiple things? The reason that's not the case, though, is all drop tables, this variable, is only ever used to get passed into this other thing. If I jump back out here, filter drop tables has a method call on it. Now that I'm hovering over this, I'm making myself upset. I just realized I have an extension method which makes testing fun. But this filter drop tables is going to be something we might want to pull out. The reason why, and this is getting a little bit ahead of ourselves, is that this random or default is a extension method. And what an extension method means is that you're actually, it's just syntactic sugar to have a method call. So actually, this method really looks like random or default, and you pass in filter drop tables, and then you pass in random number generator. So it makes it look like you are, it makes it look like you're calling this method random or default on this, but you're not. It just looks like that way. This is actually a parameter into this method. But why that sucks for us right now is that I can't actually mock any of this out. It means that my test must actually set up all the things that are inside of here, and I'm about to jump into it. I'm a little nervous because I don't know what's inside. And it's not too scary, but you can see that I do have a for each loop that's going to iterate over things. Okay, so that goes back to my scenario of what happens when there's nothing and what happens when there's multiple things. I'm going to take a shortcut for this. I'm actually only going to put one thing into that collection. And that way, that way we can do the multiple test case scenario. I don't want to go through the setup in this video of doing multiple things, so more than one thing. But when we want to test this scenario having no drop tables, that's where we're going to have some code reuse. So I'm kind of jumping around a little bit, but that should hopefully help. So I can actually make this field like I was talking about, where I have a enumerable of, is it I drop table? So I'm going to call it unfiltered drop tables. I need to instantiate it. Again, the reason why I'm doing it here is that this, when I go to make other tests, so there's more of these that are coming, they're all going to need this, right? I'm just saving lines of code, doing common setup in one spot. If I change the logical flow of what happens, inside this loop generator, I only need to change it in one spot, all this setup. So should be okay. So I want to return the unfiltered drop tables dot object. Cool. That was the one setup line. Jumping back to the class now. All that work just to get this line here. But now we're going to go set up this guy, and it's going to look very similar. So attribute filter takes in the drop table we just returned and the generator context. So attribute filter, not object, sorry, dot setup, and we're calling filter, and we're passing in the unfiltered drop tables.object and this generator context. But what does it return? Right? So that's where I'm going to take this line. This is potentially going to be different in our different tests, so I'm going to set it up inside the test. And it's going to be called filtered drop tables. And what I'm going to do that's a little bit different is I said that I wanted to pass in, actually, you know what? Let's go with the error case, okay? Let's go with the error case so that we can jump into here. We can even go sooner. Okay, so I'll explain my train of thought here. When I'm writing out these unit tests, what I like to do is find the earliest return points or error cases that I can hit. And what I can end up doing, if that's the case, is that I have one test that gets me, let's just pretend I could get down to here with one test, and then it's done. The next test I go to write that wants to go a little bit further, I can reuse a lot of that code and just change a parameter, change a setup, and then all of a sudden I get a little bit further. The next test I go write, I get a little bit further. So I keep building on top of these tests. So if I backtrack, because I was getting ahead of myself, a little bit too excited, the quickest way for me to return out of here is if this condition's not met, right? So setup, this needs to be set up too, right? Because it's going to be a property on a mocked object. And that way, if I can make sure that this condition's not met, we jump all the way to the end, right? So what that means is we can actually test the scenario that when this condition's not met, we should expect nothing to come out, right? It never yielded anything. So again, if this condition's not met from the start, we will never yield anything. And that's a real scenario. And we can assert that the number of game objects that comes out of this is empty. So let's actually do that. So I'm not going to make a mock for this. Enumerables get really weird to mock out because you actually have to set up the sort of built-in methods that enumerate. It's kind of ugly, but I'm going to set up this scenario where I'm just doing, there's no drop tables. And you can see I didn't have to put .object on here because it's not a mock. So whatever, there's no drop tables to come out. But the thing that I need here is I need to set up